The lift force and the sink force of the electromagnetic flux. There's an inversely proportional relationship between the two. Blue arrows represent the centripetal convergent lift force. It draws objects to the center, where the current is attracted to the moving convex surface of the celestial sphere. The lift force is stronger in the center and weaker at the edge. That is why planets have such an easy time staying aloft toward the center, because there's not that much sink force and plenty of lift force. If it weren't for the magnetic sun attracting the planets, they probably would crash into the celestial sphere. The lift force cohabitates with the centrifugal sink force, which has the inverse proportion effect. The sink force is the ether push force we all experience on the Earth, or in the Earth. As it moves, the divergent fluxes put the brakes on the Earth, preventing any rotation. Remember Wheeler's gyroscope on his huge neodymium iron-borne magnet? The centripetal lift force perpetuated the magnet in a viscous free flux near the center. Yet the centrifugal divergent sink force stopped the gyro on the edge. That's what's happening with the Earth. The sink force generates a depression to the west. That's why bullets sink to the west and rise to the east, because there's a greater clamping down effect for projectiles shot into the downstream of the sink force. This is also what causes eastward deflection of flying objects. They seek the least resistance, which will always be found eastward of the meridian. The sink force is so strong at the edge it holds the water at bay. The ether's sink force eliminates the Coriolis or the Atvos effect from being the cause of this phenomenon. Since you should know by now, we are not on a rotating planet. Now we can understand what causes gyroscopes to liberate themselves from the thick sink force happening at the edge. The rotation of the gyro is stripping off its sink force hold and aligning itself with a much weaker lift force at that level to allow it to rise. The vertical axis seeks to magnetically align itself with the central octahedron. That's why the airplane gyro stays pretty much vertical wherever it flies within the Earth.